This is for Year 12 methods. It comes out of the NEAP 2018 exam 2, question 4G and 4H. Okay, so the earlier part of the question talked about H being this expression and the inverse being this expression, and we now have D, which is the inverse minus the original, and it's the vertical distance between them. On my calculator, I've got D minus H. Here's my D, there's my H. So therefore that is my expression for D. So that's my answer for part 2. Find the maximal domain for D. Now, you might think that this can go from -4 to infinity, and that can go from 0 to infinity. Therefore, we'll go from 0 to infinity. However, this D is the addition of these two functions, and you can only minus one from the other where they both exist. So the domain of D will be the intersection of these two domains. So the domain of H is actually 4 to infinity, inclusive of 4. The domain of the inverse will be 0 to infinity, but the overlap is only 4 to infinity, so that's going to be 4 to infinity. Hence, show that the graph of the FH and the inverse do not intersect. If they do not intersect, therefore they're never ever equal to each other. Therefore, this expression here of D of x cannot equal 0. Okay, so I'm going to consider this value. I'd like to know what D of 4 is, plus 8 root 2. Now, I know that if I'm graphing D of x against x at 4, it's way up there. If the graph of D of x, if I put in 5, do I get a bigger value? And I get 20 plus 4 root 5, therefore it's going up. So it's not coming down. If I take the derivative, and I can prove that the derivative, so d dash of x, if that can never equal 0, therefore this can never ever go down, therefore it can never ever get to 0. So if I take the derivative, I get this expression here. Can that ever equal 0? So I'm looking at the derivative, that d dash of x equals 2 to the square root of x plus 4 plus 2 root x on top of, I don't really care what's in the denominator because I can never get that equaling 0. This will always be positive because x is bigger than or equal to 4. That will always be bigger than or equal to 0. No, bigger than or equal to, when that's 4, 4 times 2, that's 8. So this is always going to be positive, be bigger than 0, so the derivative can never equal 0. So this can never ever be 0. Since this is never ever 0, this cannot equal this, therefore they do not intersect. When I'm doing part H, what's the value of C where this equation will have exactly one solution? C is where I move h of x down. Now h of x is the bit that I'm subtracting from the inverse, I know that the biggest value, the lowest value that it will be is this. Therefore, we want, now at the moment, the closest that these two get to each other is this value here, and I am minusing h from the inverse. If I made c equal to this, I'm actually minusing this and I will double the distance away. So I want c to equal negative this. So c has to be negative 16 minus 8 root 2, and then my graph will go down to here, and at x equals 4, the d of x will be 0, which means these two will touch each other once. Now, I actually want c to be less than or equal to minus 16 minus 8 root 2, because if c is smaller than that, then this would be down here and it would still only intersect once. Because I know the derivative never equals 0, this curve will never turn on itself. Therefore, all of these values of c being less than or equal to negative 16 minus 8 root 2. Okay, just like to double check that. So, what have I got? I've got my expression of d of x, then I've made x equal to 4, and that gives me my 8 root 2 plus 16. If I was to graph, I might change my window from 4 and bigger. If I was to graph my inverse, and I was to graph my d of x, my h of x, and I go zoom auto. So there is my original and there is my inverse, and they don't intersect at the moment. So if I took my bottom graph and I added 8 root 2 plus 16, and I graphed my original plus 8 root 2 plus 16, I end up with one intersection point, which is what's saying c equals minus 16 minus 8 root 2, because I got this minus c here. I need c to be a negative value for the graph to go up. If I added something bigger like 18, so 8 root 2 plus 18, then I still have one intersection point. And if I have plus 20, I still have one intersection point. And if I go out here, the graphs get further and further apart, so I still only have one intersection point. So I think that c has to either equal negative 16 minus 8 root 2 or be less than it.